Hi, dear students. This video is about dimensioning in Inventor environment, how the dimensions are shown, how Inventor, dimensioning facility of Inventor is configured. Okay, let's start. Well, for this object, in the main part of this record, for this object, I'm going to demonstrate how the dimensions can be shown in Inventor, and also demonstrate how the dimensioning tool facility of Inventor is configured. Meanwhile, for the interest of civil engineering students, I'm going to use that one under the same title, how the dimensions can be shown. Well, here mainly my purpose in using this example on dimensioning or for dimensioning purpose, just to demonstrate in Inventor, although the model has been created using millimeter as the unit of measurement, in Inventor, well, at the beginning, for creating the model of a certain component, we make the selection from here, metric unit system or British unit system. And in British unit system, if we select this option, then while selecting the template option, in part creation environment, if we input a value as the size of a feature or the location dimension of an entity, then it is going to be considered in inch. But if we select metric option and select this template option thereafter, whatever we write as the value of a feature or the location dimension of a feature, it is going to be taken into account by the software in millimeter. Okay, then we'll say my recommendation is the same in AutoCAD, in Inventor. Well, using the default unit option, draw the projection or create the model depending on the case. But at the dimensioning stage, after drawing or creating the views, if it is mechanical engineering product, aerospace engineering product, and petroleum chemical engineering product, then show the dimensions in millimeter in metric unit system, inch in British unit system. But in architectural products, say architectural drawings or civil engineering drawings, well, the commonly used unit of measurement in metric world is centimeter. In British world, it is foot. So, well, although the model has been created using millimeter, then at the view drawing stage, well, how the units are shown, how the dimensions are shown in not millimeter but centimeter. In AutoCAD, well, I already answered this question. In Inventor, well, in this record, I'm going to answer the same question, okay, in Inventor. Okay, well, for focusing the attention of the civil engineering students mainly to the answer of that question first, okay, I'm going to start from here. This example. What is that? Well, the model of a building, it has 1, 2, 3 floors. Okay. The model of the building has been created. It was the homework assignment few years ago for civil engineering students. Okay. In Inventor, yes. Well, that time the students started from that stage. Well, they drafted the plan view of the building, say plan view of one of the floors. Okay, in that homework assignment, I said that okay, for each flat, the plan view is the same. Okay, that is the plan view, and in AutoCAD, line by line, the students had to draw the plan view, not using the solid model of the house, but say that okay, well, using two-dimensional tools of AutoCAD, be able to draw the plan view. Okay, well, having the necessary layers, dimensioning layer, windows layer, doors layer, etc. And then, well, transfer the AutoCAD file to Inventor. You know how it is done. And then, well, create the model of walls and what? Window and door openings. Yes. After having the plan view in inventory environment, applying extrusion process, and in adding mode can create the model of the walls. Well, after having the necessary sketch over the surface of the wall and applying extrusion process in cutting mode, we can create the window openings and similarly door openings. And of course, using the surface painting facility of or surface appearance tool of appearance library of Inventor, well, have such paints over the surface or on the floor, say that it is made of wood layer, can have such surface effects. One of the video records I already demonstrated how can have surface effects. And then after having the model of well, the walls and doors for one flat, then in assembly environment, okay, in Inventor, select this template option. Actually, if there were no Corona trouble and will continue on the same education way, classroom education, then sure such a model creation issue would be your homework assignment. Say it is of course for civil engineering students, but unfortunately we continue after the 10th of March. You know, we changed the education method, not classroom education, face-to-face education, but obliged to continue on distant education. Okay, so well, majority of the students, more than 70% of the students said that, hocam, my computer is an old computer, so I couldn't install Inventor, couldn't install AutoCAD, couldn't install Revit. So, well, after hearing that it is so, well, I changed the decision and then cancel such homework assignments. And also, instead of testing your learning outcome in CAD environment, AutoCAD in Inventor, or thereafter in the final exam Revit environment for civil engineering students, of course, well, I attempt to, or at least try to measure your learning outcome on the theory and also CAD application details using multiple choice exam technique. So, well, this semester, unfortunately, impossible to deal with such an homework assignment because you have no software. You couldn't install such a software in your computer. And IT department of this university couldn't enable the students to access to the classroom computers remotely. There is no such a service. So, well, I cancel such homework assignments this semester. Well, here, complete this quick demo. Well, select, after creating the model of one of the flats, say the walls and window and door openings, then well, select assembly template Actually, the details on assembly modeling at introductory level already subjected in few video records, and one of the weeks in the content, civil engineering students can find the hyperlinks, okay, to watch the necessary corresponding video records. The other engineering students as well can find, although in course MEC 113 or CVE 101 there is no chapter to educate the students on assembly modeling. Well, the ones from civil engineering, the ones from chemical, petroleum and aerospace engineering, for those students, well, saying that second course in MEC 114 assembly modeling is one of the main issue, and the things are studied deeply in that course. But that course, it is optional for the other engineering students. It is a mass for mechanical, but the other engineering students, optional course. Say, well, regarding that it is optional and you may not take such an optional course, but well, having an info and at least well, an idea on assembly modeling is really an important thing and well, valuable thing to learn. Well, I enable you to find the video records about assembly modeling. If you watch those video records, then you can see, well, not only mating details, but also project definition technique, well, project activation method, and well, pack and go process. There are lots of valuable associated things under title assembly modeling. But here quickly make a demo to say, have an idea how the module can be mated for having the model of main part of the model of a building. Select assembly template, and in assembly environment, clicking on place button, okay, and showing the address of the module, okay, one of the model of the one of the floors, flats, and then, well, located 1 if the modules are identical in shape and size, 2, 3. Yes, after having the copies of the floor, well, as a module it has been already created, then be able to position them with respect to each other using this tool. Okay, mating tool. If you have flat surfaces to relate as positioned face to face against each other at a distance or with 0 distance, then select this type and this solution in the dialog box, and then see how the rest. Indicate the, well, the top surface of one of the modules to say that this surface, and indicate the bottom side surface of the other one, this one. It is to say that these are to be in contact face to face. Well, if you write the offset value into this box, for instance, say that 30, then there will be 30 millimeters empty space between them. But say that 0 distance, so these are to be in contact. Okay, and then click on apply. The other direction, well, this surface of the wall of the second flat is to be in the same plane that of the other flat. So parallel positioning, indicate the surface, indicate that surface. These are in the same plane. Apply. And then this surface and that surface are to be in the same plane. So this solution, this type is the correct type. This is the correct solution option. And then indicate the surface, indicate the surface. Yes, you see, managed to assemble or position one module with respect to the other. Continue for the third. Well, select face-to-face contact option. Indicate the surface. With face-to-face solution. Indicate the surface. Indicate the bottom side surface of the other flat, the model of the other flat. Okay, and then say that okay, these are to be in contact. Click on apply button, and then similarly select parallel positioning option. This surface and that surface are to be in the same plane. Apply. Okay, this surface and that surface are to be say, well, do it again, I made a wrong click. Parallel positioning, say that this surface and that surface are to be in the same plane. Apply, and then say close this dialog box. Yes, you see, managed to position the models of the modules with respect to each other. And then, of course, after having the main part of the model of the building, then deal with the other things. How about the roof construction, roof structure, doors, windows, furnitures? Actually, that student almost completed the model of the building. Well, in assembly environment, after having the model of something, well, it is an assembly, can take the visibility of the components. For instance, take the roof away from the screen. How? Indicate right click and the select visibility option. Then it is to see the inside. Yes, that student, well, not only the modules, but also creating the models of some furnitures in Inventor. Yes, patiently and very satisfactorily assemble the furnitures into the rooms. This is to say bedroom, and this is a bed. Okay, this is say washing room, bathroom, and this is bathtub. Okay, living room, table, armchairs, sofa, lighting fixture, etc. Okay, well, take the visibility of this module and then see that second floor, yes, furnitures, kitchen, oven, etc., etc. These are all available in Inventor environment. Yes. But here at this point, open a parenthesis. In Inventor, if you try to create the model of such a building, it has 1, 2, 3 floors, including the roof structure and the furnitures, etc. In Inventor, it may take, well, even half of a day or more. But if you select Revit for the same purpose, in half an hour or few hours it may be finished, and much more realistically. For civil engineering students, last 2 weeks of the semester, I'm going to well, introduce the tools of Revit, the Revit environment. Well, if it is asked, yeah, which software is recommended for creating the model of a building or a house, Inventor or Revit, the answer is on Revit, certainly Revit, not Inventor. But say this is to demonstrate that in Inventor, yes, why not? It is possible. Now here, after introducing this example for your interest, especially the interest consideration of civil engineering students, then, well, I'm going to create the plan view of one of the floors in Inventor, and then answer the question. Although the model has been created in millimeter, yes, well, take an inspection tool to your hand, you know how, inspect, and ruler, and then see the size from this limit to that. Distance is 9,400 millimeters. Okay? Near to 10 meters. It is in millimeter. Okay. Civil engineering applications or architectural applications, you know, already learned such thing. It is the convention. Show the dimensions not in millimeter but centimeter. Now, well, in AutoCAD, you learn how, although unit of measurement in the template, drawing template is millimeter, how the dimensions can be shown in centimeter. In Inventor answer, for this model, I'm going to create the views. I selected first quadrant option. Metric means you selected first quadrant. I'm going to obey to the rules of ISO, select the ISO template option, drawing template, and then click on create. Paper in A3 size. For such a big object, the A3 size is not a good selection to its working area because it is a very small paper with respect to the size of the object. So edit sheet option, and from here I'm going to select A0 size paper or more, greater A0, 2 A0, 3 A0, 4 A0. Try A0. And then start the view creation process. You know how, clicked on base, and then, well, which view? I'm going to, well, show the elevation view of the building here. Okay, 1 to 50, Inventor offering 1 to 50 as the drawing scale. Okay, or say that customize the paper, have greater size, not A0 but custom size option. Select custom size option. The height of the paper, say that 3 times greater than the height of the A0. Okay, with, let's say, 2 times greater. Okay, such a drawing paper, and then start the view creation process. Elevation view. You see now Inventor offering 1 to 20. Yes, it is commonly used scale factor. Okay, try to 1 to 20, 1 to 10. Okay, 1 to 10. This is the elevation view. Okay. Drawing the assemblies, well, we omit the images of hidden entities. It is a convention. Show the images of visible entities. How about the plan view? It is a sectional view, you know. Create the sectional view. But here, for the sectional view, the empty space may not be sufficient. So I'm going to increase the height, saying that 3000 millimeters is the height of the paper. And then, well, see, start sectioning process, clicking on, you know, this, indicate the view, and then, well, select the cutting plane. I'm going to create the plan view for the first floor. Well, this is the cutting plane line. Right click and then say continue. Yes, and then the plan view. Yes. say that plan view is over there. Well, solid parts cross-hatched. Inventor, okay, knows that it is a sectional view, and on sectional view, solid parts are to be highlighted. For any kind of material, equally spaced inclined lines can be used. But architects, if architects say like to show say highlight the material of the components, say that it is made of gypsum, it is made of brick, it is made of concrete. For different construction materials, in civil engineering or architectural applications, we have special hatching styles. Okay, replace the general hatching style with the specific one. But here my purpose is not to demonstrate how the hatching lines can be replaced with the other. My purpose is to answer the specific question. Although for this template default unit is millimeter, how the dimensions can be shown in centimeter. Although the model is in size millimeter, creating the model will use input the values in millimeter, but say obeying to the convention of civil engineers, show the dimensions in centimeter. Answer this question. Okay. But first need to talk about or deal with dimensioning configuration. Similar to AutoCAD, since Inventor is used not only by mechanical engineers, but why not can be used by civil engineers, the architects, and the other in other engineering branches. Well, in the configuration dialog boxes, we find the options not only for the mechanical engineering applications, but for the others as well. So need to teach to the software which option is the correct option for a certain drawing. Okay, dimensioning configuration. Well, answer this question for this object first, and then refocus the attention to this plan view. Okay, this is not a building, this is not a house, the model of a machine element. Well, in AutoCAD, mainly talking about the dimensional configuration, I use the same object, Well, here in Inventor, of course, say first create the views. For this object, I'm going to create the views. Well, using that model, can create the views in few seconds. From this, after clicking on New File Creation button, from this list in the dialog box, View Creation dialog, select the quadrant and also the unit system. Metric option means we selected metric unit system in which the dimensions will be in millimeter, but in civil engineering the dimensions are shown in centimeter, and the quadrant in which the object going to be considered not only by the designer, say the reader, but also by the software. Okay, Inventor will know that first quadrant has been selected. And then drawing template, without having a paper simulation, impossible to create the views of something. It is a must, not optional, it's a must. We must have a paper simulation. Select this template option, in metric world, obey to the rules of ISO, and then create the views. For that object, it is sizes, measurement tool, from this limit to the other limit. It is just the overall width of the object is 145. Okay. Center to center. Reset it from here to this limiting point, 175 millimeters. So the object is not so big. A3 size paper is sufficiently large. sufficient for having the necessary views. For this object, 3 views are necessary and sufficient. Start the view creation process. Okay, teach to the software which side is front side. Well, for your convenience, enable yourself to see the simulation pictorially, clicking on house symbol. And then home positioning, you fix the home positioning of the solid model, so you know which side is front side. In this example, I said that this is the front side of the object. So to be able to create the front view first, it is to be base view. See the parallel surface of the viewing cube, and then make the parallel surface of the viewing cube. Clicked on the parallel surface of the viewing cube and make the frontal side of the body as parallel to the drawing paper. Scale factor 1 to 2, but I checked 1 to 1 is also possible, a suitable scale factor for fitting the necessary views. And then this is for the front, this is for the top, this is the place for the left side view. First style button must be on, and then say OK. After creating the views, then show the symmetry axis, longitudinal axis. To say that this rectangle is the image of a revolved feature, it is the image of lateral side view, front side view. It is on the front view, the lateral side view of counter bore. It's a revolved feature. Show the longitudinal axis, and the rest is drill. Show it as longitudinal axis. Okay. What else? Say here and there we have the limits of one of the holes within semi-cylindrical extension. This hidden rectangle is the image of this this hole. So to say that it is not the image of a rectangular prism but a hole, show the longitudinal axis. Okay, this arc is the edge of semi-cylindrical surface. Yes. On the left side view, we have the left side view of the contour bore hole. To say that it is a revolved feature, show the longitudinal axis for the interest of readers. Reader looking at the image and finding over a rectangle longitudinal axis can directly conclude that it is the image of a revolved feature. On the top view, show the limits of the holes to highlight that those are revolved features, longitudinal axis. I think it is okay. The horizontal vertical symmetry axis, if there is a full circle or semicircle, then show the horizontal vertical axis. Okay, show this full circle and have horizontal vertical axis. Show this semicircle, have vertical horizontal axis. Okay, show this one, have horizontal vertical axis. And then press escape button, and then for having the symmetry axis for this outer semicircle, I'm going to use stretch technique. I hold it and stretch it. Hold this one, stretch it. Or instead of using stretch technique, say oops, oops, oops. Then clicked on this and indicate the semicircle. Okay. Yes. Stretch or semicircle. Actually here I'm going to delete this one, and this is more convenient. Indicate the outer circle or circle arc, semicircle, have the symmetry axis, and for the other one, the inner one, use stretch technique. Otherwise the symmetry axis may coincide onto each other, and short dash may clash with long dash, and the line may appear as a continuous thin line, as if. So it is a poor practice. Okay, yeah. Say that managed to show the axis of symmetries, and then the rest dimensioning. Okay, or first fill in the title block using text facility, show quadrant symbol, or first show the dimensions and then deal with the title block filling stage. I'm going to skip title block filling stage because it is not the content of this week. Okay, the content of this week is on dimensioning. So dimensioning in Inventor, after having the views and the symmetry axis, necessary symmetry axis, then this means time is the time to configure the dimensioning facility of the software. Okay, see how. Clicked on Manage tab and then find Styles Editor button and then clicked on Styles Editor. Not for the first time. Talking about text facility of Inventor, I already addressed this style editor option. If you're going to configure the text facility, select this one. If you're going to configure the dimensioning facility, select that one. You see in the list it is written dimension. Okay, clicked on the associated cross, drop the list, and then from the list select the last option, default option. And then after this selection, then can find the configuration options in the larger pane. Start from here, units. If you use millimeter in creating the model and obeying to the convention in mechanical engineering, aerospace engineering, use millimeter in showing the dimensions, then keep this automatically selected unit of measurement. Inventor, considering that the model has been created in millimeter, then automatically selected millimeter. Okay. For showing the nominal values, if necessary to show the decimal parts, then separate the integer and decimal parts with a dot. So drop this list and select not comma but dot option, period option. In engineering we use period. And then here precision. Studying on the dimensioning part in AutoCAD using the same example, already concluded that referring to the slide in my lecture note, this slide, sorry, I had an interruption. Yes, this one. ISO says that if deviation starts from tenths, then show the nominal values integer. If deviation starts from hundredths, show the nominal value as a decimal number with the figure at its decimal part at tenths, and so on. So referring to the table 1 for non-functional dimensions, we concluded that almost for all the features it is true. Not a matter tolerance class, fine, medium, coarse or very coarse, deviations starts from tenths. So in our example, in our case, show the in this dialog, show the since we need to show the nominal values as integer, in this dialog from the list drop and select no figure option at the decimal part. If you select this option, then the nominal value will be shown as an integer. For angles, yes, we use decimal degrees, so it is correct. Precision, if for the angles, the deviations are just using the tenths of degrees, so need to show the angle, nominal value of the angle as integer. So select 0 figure option for the decimal part of angles. Okay, in this dialog, these are the things to do to deal. Clicked on alternate units button. Okay, seldomly it may be necessary. For instance, some technicians, some readers familiar with in their convention the millimeter to see the dimension in millimeter. The others want to see the same dimension in inch. Along the same dimensioning line, for having the dimension of the feature not only in millimeter but also in inch, well, deal with this dialog. Otherwise, then skip. Okay, display option. Yeah, yes, this dialog. Well, we have some things to deal. For instance, at the beginning of extension lines, we always leave a space. Although it is so, well, automatically select the space value. Well, this yellowish one corresponds to a part of a certain orthographic projection, and for this part, well, the dimensions are to be shown. Well, distance p is the space to have at the beginning, to leave at the beginning of extension line. Certainly not 0, but maybe 2-3 millimeters. For this example, 2 millimeters suitable. Okay, well, extension lines are furtherly extended beyond the termination symbol of dimensioning lines. How much? Well, 2-3 millimeters. 2 I selected. For the first dimensioning row, the space to leave or to have between the outmost boundary and the dimensioning line is 10. For the successive ones, it is 8, minimum 8. For underlining purpose, in case if the model is in wrong size, but the projection, on the projection, the dimension is to be shown not with the wrong value, but the correct value, then the dimension is to be underlined. For having the allowance for underlining symbol, well, such a gap is necessary in ISO format, less than 1 millimeter. This is okay for me. Well, for mechanical engineering drawings, chemical, aerospace, termination symbol is filled in isosceles, so field option correct. But for civil engineering or architectural drawings, oblique tick, inclined tick option is correct. Okay. Configuring the dimensioning facility for the other example where I have the model of building and it is plan view, I'm going to select this option. But here, since it's a machine element, I need to select field option, close field option. Arrow size for A3 size paper 3, okay, and the other size of the isosceles, it is the termination symbol, is 1. Okay. Internal chain terminator. I'm going to explain what does it mean. For internal chain terminator, select large dot or small dot. Okay, I selected small dot. I'm going to explain what it is later. And then how here in Inventor, if in your company you have a color printer or plotter, so can take the printouts or plottings, have the plottings in color. For different lines, you can select different layers, can select different colors. Similarly, here in this dialog, if you clicked on color tab and then select the color option, then extension and dimension lines going to be created in that selected color. Here, I'm not going to make such a selection, so Inventor, using its default configuration, will create the extension and dimension lines in black. Okay, text. If selecting this option from this list and then having the text configuration dialog, how talking about text lettering part in the content of the course, that chapter, I already demonstrated how you can configure text facility. If the text configuration has already been done, then skip this option. But since in this example, for this example, didn't pass through such a stage, then well, here I'm going to deal with it. If in AutoCAD, clicking on such a button on which we have triple dots can say route the buffer from dimensioning dialog to text configuration dialog. Similarly, in Inventor, clicking on this button, not 3 dots, but we have pencil point symbol, then yes. Well, after changing the configuration, don't forget to click on Save button. Since I forgot to click on Save button, Inventor noticing me. Shall I say yes? And then you see buffer jumped from dimension option from the list to text option. And then this is the text configuration dialog box. Well, from this list, select Arial as the font name. You know, it is recommended font name. Text height. Well, if it is the configuration for showing the dimensions, then you can fix it. Otherwise, don't fix the text facility. Okay, height value. For instance, you're going to fill in the blanks of title block, so do not fix the text height in this dialog, because depending on the size of the text box, you may need to use not 3.5 but 2.5, not 5 but 7, okay, depending on the size of the text box. But here, while this configuration is for the dimensioning numbers, 5 millimeters is the reasonable height value, font height. In AutoCAD, you know, into such a box, well, it is a must to write recommended font height times the inverse of scale factor. But in Inventor, well, directly write the font height, because Inventor is new generation software and Inventor does not apply the scale factor on the text or numerals. So just write the font height into this box. Italic style is recommended, and then yes, clicked on Save button, and to be able to jump from text configuration dialog to the back to the dimensioning dialog box, clicked on Back button, and then yes, the rest. In this dialog, all the other automatically selected options are acceptable, are correct. Do not change the options. Okay. How about say? Well, this is first quadrant drawing, so in accordance with ISO, you know, we show the dimensions above the dimension line. So this option is selected option is correct. But if it were third quadrant projection, okay, then well, here I would select from this list that option. Okay, to say that, because in accordance with American Association, while the dimensions always are shown as horizontally written, horizontal oriented, I would select this one. But in ISO, well, dimensions are written above the dimension line and always in alignment. So select alignment option, parallel option. If it were third angle projection, okay, obeying to the rules of ANSI, I would select this option to have the dimensions as written over the line, not above the line. But this is first quadrant, so select above the line option. Okay, well, clicked on after making site changing Save button, and then continue. On tolerance dialog box, I say do not make any changing. Okay, while showing the dimensions of functional features, then can individually deal with the format options. Options option, all the things selected by the software are correct. Notes and leaders tab, well, the only thing to change is this one. You know, leader line is to have not only inclined part but also horizontally oriented tail. So select horizontal option. The automatically selected option is wrong. For leader lines, inclined and horizontal tail should be. Okay. And then, yes, in Inventor, that is it. Clicked on Save and then close this dialog box. This means thereafter you're ready to show the dimensions. Okay. Before showing the dimensions, on this example, refocus the attention of the civil engineering students to the plan view. Well, here, if quickly configure the dimensioning facility, manage styles editor, you learn the details, how the dimensioning tool of Inventor is configured. Well, knowing the things, then quickly pass through. Select this option and then separation symbol is dot. Okay, here to be able to show the dimensions not in millimeter but centimeter, from this list select centimeter. That is it. Precision 0. Okay, for the angle 0. And then display option. Here not arrowhead. In civil engineering architectural drawings, we terminate the dimension lines putting inclined tick. So select this tick option. Okay. And display at the beginning, well, have empty space in the order of, let's say, 5 millimeters or more. Minimum space 8 millimeters. Okay, for successive dimensioning rows. 10 millimeters for the first dimensioning row, so on and so forth. Okay. Text configuration. Yes. Arial. Font height, let's say 10 millimeters, because it is over 4A0 size paper. Not 5 but 10 may be more suitable. If not, then can use 14, maximum 20. And then yes, this is okay. Clicked on save button and return back to dimensioning dialog. And then, well, the other things, well, horizontal leader line, and then clicked on save and close button. And then, since at the stage configuring the dimensioning tool I selected centimeter, then although model has been created in millimeters, when I indicate the dimension, for instance, the distance from here to there, from here to there, yes, and then say OK. See, architectural tick is the termination symbol, and the dimension 390. Okay, in the model for this part, see the distance. Yes, from here to there. On the technical drawing, 390. I'm sure it is in centimeter. Yes, in the real model, say the model of the object, see the distance from here to this limit. Distance. Well, sorry, it is not the same part. Sorry. The dimension which I showed on the plan view is the size of this one. Indicate, you see, 3900 millimeter. 3900, but here managed to have the dimension 390. It is in centimeter. Yes, this is the thing to do in Inventor for architectural drawings. Centimeter, show it in centimeter. And of course the other dimensions, windows, etc. Well, not in this video record, but in other video record I'm going to well, show not only one dimension on a plan view, but the other dimensions as well. Okay. So, well, refocus the attention to this one. And then start dimensioning. Annotation. Clicked on annotation tab, and then, well, in Inventor there is only one button to click. This is powerful dimensioning facility, and using this facility there is no trick. You know, in AutoCAD, if you select power dimension option, then for showing the diameter, for showing radius, for showing angle, the trick is that first press enter. After starting the dimension indication process, clicking on power dimension tool, press enter and then indicate circle arc, or well, the raise of an angle in AutoCAD. But in Inventor there is no such a trick. Just start the process and then indicate. For instance, what? Indicate the boundary of the semicircle. Yes, Inventor understood that it is a circle arc. So for a circle arc, we show the radius with the preceding symbol R. Okay. And then after clicking in Inventor, find the Edit Dimension dialog. If the dimension is not to edit, it is correct, then click on OK. And then continue. No need to click on the same button again. Indicate this one. Okay, it is the hole, and well, show the diameter of the hole here. And then say OK. And then, well, indicate this terminal points. Yes, Inventor understood that it is a linear distance, you know. Well, in Inventor, how can understand that or sure that dimensioning line is 10 millimeters away? If it is not 10 millimeters away, then in the simulation, see the extension and dimension lines as continuous line. But you see slowly moving the cursor together with the simulation. Now the things are in dotted form. This is the indication in Inventor that the distance between the outer boundary and the dimensioning line is 10 millimeters. If you're going to place the dimension line to its dimension at this place, then click your mouse. And after the click, the dialog box appears. Well, this strange symbol corresponds to the measured distance, dimension of the feature, much less than, much greater than symbol. All the things are okay. If there is nothing to edit, then click on OK button. OK, and then continue. Well, distance for this one. By the way, this is a valuable info. If along the projection of an entity there is no interruption, there is no cutting. For instance, well, from here to there we have a line, but this part of the line corresponds to the boundary of a surface. This part the boundary of another feature. This part another feature. This part another feature. If the line just the images of different entities, well, in the model you see, well, part of the boundary is the boundary of the surface. The rest is the edge of this surface, the projection of this intersection, and the boundary of this part of the surface. So, well, although on the projection we have a single line, but that line partially corresponds to the images of different things. So, well, if your purpose is to indicate the dimension from here to there, then you must indicate the terminal points from here to there. But if the dimension is the one, well, for a boundary, and it is the image of the not more than one entities, but only one entity, instead of indicating the terminal points, click, just indicate only one point, not at the terminals, but any other point. One click is enough. Then Inventor understood that it is the dimension. You can save time. Okay, this distance. Okay, and then indicate this one, indicate this one to show the location dimension for the other semi-cylindrical extension. Well, this semi-cylindrical extension. Continue. Indicate the radius of this one. Yes, and then location dimension for the contour bore hole. Yes. And then, well, the overall dimensions must be shown, you know, from here to this tip point, yes, it is the width of the object, is to be shown. But you know, since 30 plus 145 makes the overall is result of this summation equals to the overall width. Now here overall width by definition is reference dimension, and you know reference dimensions are to be shown within parentheses. How you can achieve to take it into parentheses? Select precision and tolerance option, okay, and in this pane select reference option. If you select reference option, then Inventor will take the dimension into parentheses and then say OK. Well, in AutoCAD, you know, whenever you perceive that, well, the space between the views initially you had is not sufficient for showing the other necessary dimensions, then, you know, apply move process, well, be able to move not only the projection but the transfer lines, associated transfer lines. It takes a certain time, but in Inventor it is quite easy. Press escape button, finish any running, and then hold the base view with a click, and then, well, making such trials, shifting the views, okay, make the space between the views sufficiently large, yes, and then continue. Re-clicked on this. Well, need to show this dimension from here to there. Yes, I show it. Okay. Height of the object, but first, well, the location dimension for the axis of the semi-cylinder and the coaxial holes, this dimension, and then say OK. Well, I forgot to indicate the height of the strengthening flex, so indicate, but here the same case. Never have such an intersection. Located, well, if by mistake you show the greater distance first and then shorter, then they may interfere. Press escape button and then, well, hold the dimension with a click and then you can move it. Okay, following this dotted line, you can make the space between this dimension line and the boundary larger to be able to find the space for showing the dimension of smaller feature. Yes, these are editing technique. If you need to take the dimension into edit mode again, for instance, for this one, how? Double clicked on the dimension, then you find the same editing dialog box if necessary. Okay, and then show the height of the object, overall height from here to this tip point. Now 95. Since 95 is equal to 70 plus 25, to say that the upper and lower limits for this overall dimension are determined adding the upper and lower limits of the constitutive dimensions. In our example, these are 70 millimeters and 25 millimeters. Well, just to say that it is reference dimension, you know, show it between the parentheses. But 60 is another overall dimension, the overall depth of the body, but it is not reference dimension. Okay, continue. Well, showing the height of this one, I'm going to use the same thing, same scenario. It is 30, okay, at present. Okay, but at that stage in the dialog, see, 30, it had to be 32. What can be done? In AutoCAD, you know, prevent AutoCAD from showing the wrong dimension and enforce the software to show the corrected one. And in doing this, don't forget to underline the symbol. Say, underline the dimension using underline symbol. In AutoCAD, Well, in such a case, what can you do? Since in AutoCAD, making a correction on the views to have the dimension thereafter in the correct order is a time-consuming thing. Even for one dimension, the editing time in AutoCAD may be in the order of 10 or 15 or even 20 minutes. But in Inventor, it is not so difficult. Well, it is offered either correct the solid model in size or use the same allowance on showing the dimension of that feature, enforce Inventor to show not the existing value but the correct value with the underline symbol. First demonstrate, one more time to highlight that program is a new generation software. So already created views and the shown dimensions are inherently up to date whenever the solid model is edited. Well, say that OK, and then 30 is the wrong dimension because the size of this part has been created in the wrong size. How it can be corrected? One way is that one. Turn back to the modeling environment and then find the icon. It corresponds to that part of the model. Right click the mouse when the cursor is on the corresponding icon at the browser and then say edit feature. Why it is wrong? Because at the extrusion stage, not 32, but it has been by mistake written 30. OK, then replace it with 32 and then say OK. Now it is 32 millimeters. Turn back to the drawing and you see it is automatic 32. Yes, this is recommended, of course. Correct the mistake in solid model so the drawing will be automatically corrected. Other case, if you couldn't find the time to correct the solid model or you forgot how the solid model is edited, then yes, you may use the other technique. What is that? Still in edit mode, first clicked on this box, height dimension value. It is to prevent software from showing the wrong size, that wrong value. You see, didn't correct the model in size. Model still is wrong in size, so the image of the model is wrong in size, but here using the allowance, I'm going to correct the dimension. After hiding the measured value, clicked on this pencil point button and then in this dialog box, by typing, write it. In AutoCAD, write the number first and then clicked on underline button, but in Inventor, first underline button and then write the value 32 and then say OK and then say OK. That is it. You see now dimension is 32, although projection is still wrong in size. An underline symbol, it is to draw the attention of the reader that the dimension is 32, but on the projection it is not equal to 32. Projection is wrong, but the dimension is correct. Okay, how we can have the annotations for holes? In AutoCAD, clicked on leader text button and then typing the text and having the symbols, write it. If you want, you may select the long way. Yes, using leader text tool is in the analogy means you selected long way. I'm going to answer the question why it is long way, but first see how. Clicked on this and then start the process. Indicate the edge of the hole on the view where we see the edge of the hole. And then move the cursor away sufficiently, 10 millimeters minimum from the outmost boundary. Have such an inclined part, left click and then right click the mouse. After right clicking in Inventor, don't forget to click on continue button. And then yes, text dialog box. Okay, If you remember the size of the counter bore hole, then well, by typing. If not, then turn back to solid model environment and using inspection tool, try to call your memory. I remember the size. Okay, well, first diameter symbol. Drop the list of the symbols, clicking on this listing arrow, and then find in the list diameter symbol. And then diameter of the drill, it is 20. Click on comma. Drop the list one more time and find counter bore symbol. And then from the table diameter symbol, bore diameter is 30. Clicked on comma. Redrop the list of the symbols, clicking on this. And then find depth symbol. You know, in accordance with ISO, we use such symbols in writing the specification technical note for holes, counter bore hole in our example. And the depth of the counter bore is 5, as I remember. And then say OK. Yes. And then say oops, and then see the things in shorter way. In Inventor, there is such a tool. If sure that hole has been created, applying hole process. You see here, I have hole icon. Yes. Using the hole creation tool, here is the push button for that facility. Created the counter bore hole. And that's its icon. If hole has been created, not applying extrusion but applying hole creation process, then yes, at the dimensions stage, sure, there is a convenience. Clicked on hole specification indication button, not dimensioning but hole, not leader line but hole, this option. And then see the magic, indicate after that the edge of the hole with a click, and then move the cursor, click, that's it. Well, the annotation data will be gathered from the solid model and the necessary annotation will be written by the software. Quite convenient. Okay, and then here demonstrate how a functional dimension can be shown. But first let me save the file. I made the same mistake. I forgot to save the file in the memory. Do not take a risk unexpectedly, because program may crash or electricity may be off and you lose the data. Okay, file name, surname, ID number, section number, etc. And it is about dimensioning in Inventor. Date is the 20th of May, May 20. Okay, and then, well, all of such things are non-functional. How about functional dimensions? The channel opening from here to there is a functional dimension. How it is shown? Annotation, dimension, and then indicate the terminal points, and then yes, 60. Inventor will consider it as if it were non-functional. If it is functional, then clicked on, well, precision and tolerance tab. Okay, and then if in your company still the senior engineers, old guys, keen on using old format of ISO, then select from this list deviation option. Yes, and then Inventor understood and then show the deviations. Well, upper deviation box, lower deviation box. Upper deviation, say that 0.0123 or 1, 2, 3 figures. Okay, and then lower deviation minus 1 0, let's say, or 1 2. Well, 3 figures, let's say 0.012. Say this is, say that the lower deviation 0.011. Okay. Although I type 3 figures, why still see 2 figures? Because you see here the precision, well, for the deviation values automatically selected number of figures is 2. If you need to show 1, 2, but not 2 but 3 figures, then select this option and then start seeing the deviation with the necessary figures. Okay. Here, well, during the dimension configuration stage, you know, for non-functional dimensions, we said that deviations start from tenths, so show the nominal values as integer. So at the time we selected the precision as no precision, 0 precision, for via which we had the nominal values as integer. But for this functional dimension, since the deviation starts from hundreds, need to show the nominal value as integer with one, say not integer, decimal number, with one figure at its decimal place. How we can have a figure at its decimal place? Drop this list, primary unit list, and then select one figure option. Yes, then in AutoCAD, writing the figure, value of the figure, but in Inventor it is written by the software, and then say OK. Yes. In old-fashioned format, well, this is the thing to do, or no, for functional dimensions. Save this file, sync dimension, functional dimension, old format, and then how about the format of today? I'm going to edit it. Double clicked, and then in the dialog box, well, here after selecting precision and tolerance tab from the list, do not select deviation but select limit fit show size limits option. Yes, if you select this option, then Inventor can understand that you're going to show the functional dimension using the format of today with IT grade. And also, well, the good practice, you know, for the convenience of the ones, they are not so good on determining the upper level limits, showing the upper level limits in the parentheses. But Inventor, similar to AutoCAD, arbitrarily select the IT grade, H7. Well, here under your control, first check whether the dimension is the dimension of a feminine feature. If yes, yes, make the letter grade selection from this list. If the functional dimension is the dimension of a muscular feature, solid feature, then make the selection from this list, because, well, the IT grade letter for muscular features is to be lowercase letter. But since it is an empty space, feminine feature, yes, capital letter is correct. So make the grade selection from this list. By the way, you can see the IT grade spectrum, A1 to A18, B1 to B18, C1 to C18, and so on. Lots of IT grades. Well, in this example, the selected IT grade, okay, for having the necessary mating is H8. Yes, after selecting H8, then the limits you see calculated by the software automatically and the limiting values are in the parentheses, and then say OK. Yes, that is it. How the angle show, annotation, dimension. Showing the angles, there is a trick. Do not indicate the terminal points or midpoint of the rays. If you indicate terminal points, then Inventor conclude that it is a linear dimension. Indicate the rays, not terminal, not midpoint, but another point. Indicate this ray at such a point, for instance. Indicate the other ray at not terminal, not mid, but another point. Then yes, that's it. Inventor can understand that it is an angle. And then with a click, locate it, and then say OK. Yes, there are some other dimensions, but at home you may complete them, because there is no new thing to educate you on such things. OK. Save the file. One more time, saying that functional dimension, not old method, new method. New format. And then, well, here I'm going to focus the attention to the case. You have tiny entities. Okay, now I'm going to modify this model. See how. Take a sketch right on the surface, and then, well, in sketch mode, apply projection process, have the image of the sage. Okay, I'm going to use this as a shoulder in applying trimming process, and also a reference for inputting dimensional constraints. Create a rectangle arbitrarily, one more rectangle arbitrarily, one more rectangle arbitrarily. Why? Explain. Trimming process. Start trimming process, and then trim the unnecessary parts to locate the terminal points precisely along the boundary. Yes, these are the necessary sketches for creating little channels. In the design of the object, well, need to have little slots in size. Dimensional constraint, from this limiting point to this boundary, distance is, let's say, I don't know, 6 millimeters. Okay, and the width of the channel is equal to 4 millimeters. Distance from here to there is equal to 10 millimeters. Oh, well, not 10. Say that 12 millimeters. And the opening of the channel, in my consideration, those lines just corresponding to the edges of the surfaces of the slots. Okay, say that it is 3 millimeters. And distance from here to there is equal to 2 millimeters. And this one is in the size of, let's say, 4 millimeters. Height of the channels, from here to there, you see the projected line is the reference to input the constraints. This is equal to, let's say, 3 millimeters. The height of this one is from the same reference, let's say 6 millimeters. Okay, so on and so forth. This is in the size of 5 millimeters, etc. Finish the sketch. And then apply extrusion process. Show this profile, show this profile, show this profile. Not in add mode, but cutting mode. and say truly cut. Clicked on this button and truly cut it, and then say OK. You see, I created tiny fine entities. At the bottom side there are tiny channels. OK, and then save the file. You see, I changed the design, I modify it. Already created drawing will be automatically up-to-dated, yes. And then, well, what is the thing to deal? Need to show the dimensions of those. So, well, slide this to have more space for showing the dimensions of the newly created ones. And then try. And then see the difficulty, dimension. And then, well, this distance is to be shown. At this point, please be aware, if Inventor cannot find the space between the extension lines, you know, for having the arrows outwardly directed normally, need to have the space between the extension lines minimum 3 plus 3, 6 millimeters. But the space from here to there 6, and Inventor understood that the arrows cannot be outwardly oriented because two arrows cannot fit into this limited space. So it is allowed in such a case show the arrowheads inwardly oriented. For this dimension, no problem. And then say OK. But for the next, from here to there, show the width of the channel. And then yes. But since we have the precedingly created dimension, and when we locate it over here, then yes, the arrows will interfere. You see? And then continue. From here to there, show the distance, one more interference. And this is quite misleading, not understandable. Reader looking at this part then may attempt to say, it is 24. It's quite misleading, and it is, you see, impossible to see the extension lines because the entity, the scale factor is not suitable, and for this tiny fine entities, under that selected scale factor, it is suitable for the rest of the body but not suitable for this part. What can we do? If the arrowheads cannot be fit between the say at the spaces bounded by the extension lines, then such a case, well, in mechanical engineering drawing, it is the common practice, arrowheads are replaced with dots. See how? Undo, undo, undo. And then such a case, if it is the case, then, well, select this option, chain dimensioning, chain. Okay. And then indicate this one, this one, this one, this, and that. And then press enter. Sorry, right click the mouse and say continue. Right click the mouse, continue. And then yes. Well, you see, Inventor understood that the space for arrowheads not sufficient, so automatically if you select chain option, okay, showing the lines, say dimensions of the features like a chain dimensioning. Well, for the first termination symbol and the last termination symbol, yes, arrowheads, but the intermediate ones, dot. It is allowable and it is a common practice. Dots are used in case at the intermediate parts as the termination symbols. Okay, have an idea. Say not the arrowheads, but we use dots. But the other problem is still exists. You see, the numbers are very close to each other. So this dimension cannot be understandable. Which dimension is for which one? Very close and even might interfere. So well, the best thing to do in such a case, well, detail view. You know, if there are tiny parts, okay, and under the selected scale factor the image of the tiny part is not so distinguishable, and also well, the dimensions, showing the dimensions, the space not sufficient for the numbers and for the termination symbols, detail view is recommended. Now, well, the best solution for such a case is detail view. Well, I think can slide this view here to have empty space. Using this empty space, I'm going to create detail view for this part. See how? Place views, clicked on detail view creation button, and then indicate the view on which view you're going to define the region. That is the region. At this region we have tiny features, and the images of those are to be shown under a greater scale factor is on the front view. So I indicated the front view, and then, well, scale factor. The scale factor for the existing view, reference view, is 1:1, and Inventor offering 2:1. No, not 2:1, but I'm going to create the detail view under scale 3:1. And the regions are identified with letters and the corresponding detail views as well. Letter A for the first detail view, letter B for the second detail view, and so on. Well, bounding the region with a continuous smooth circle, not a rectangle, but most of the cases it is the common convention, common agreement. We bound the regions with smooth circles, so select circle fence option, not wavy but smooth fence. And then it is, if there will be more than one detail view, say joining the detail view and the region with straight joining lines is a good practice. A reader following the straight line can easily reach to the corresponding detail views. For having joining lines between the region and the corresponding detail view, select this two little boxes with clicks, and then the rest. Don't click on OK. Bring the cursor to the center of the region, make a click, and then move the cursor after the click outwardly, well, till you take the entity, images of tiny fine entities, into the boundary, and then click, and then the rest. Move the cursor to the vicinity, and over there find an empty space. Yes, the detail view will be created over there. And then on the detail view, well, show the dimensions. Well, I make the projection large enough. Well, I may show the dimensions using arrowheads. But if it is going to be chain dimensioning, it is more convenient to replace arrowheads with dots. Okay, I'm going to select this option, chain dimensioning, and then say that this, and that. Okay, show the dimensions, right click the mouse, and then continue. Yes, you see no interference, and the numbers are sufficiently away from each other, and dots more suitable to use. Okay, no problem. Height values. Okay, show the height of this channel, dimension, this to that, 5 millimeters, and then say OK. Height of this one with respect to here, be able to show it. If not, then extend it to the outside, so on and so forth. Yes, and in the vicinity of this view, yes, the same letter is written and the scale factor as well. But here the size of paper not sufficient to fit, well, try to shift the views a little bit. Well, such a case, to be able to prevent clash, it is allowable. We can unbalance the views over the paper, okay, to have more space. If it is still impossible to prevent the clash, then this means you need to use a greater size paper or decrease the scale factor. I'm going to take this node from the margin and bring it to the vicinity. It is going to be more distinguishable. Region A, detail view A. Okay, save the file with a different name. Tiny. And then finally, before finishing this video record and say that you learned the necessary things on dimensioning in Inventor, well, say that have an idea on this convenience. Well, delete these dimensions, at least some of them, for demo purpose. You see, well, previous example, I individually, one by one, indicate the entity and had the dimension, one by one. It is recommended, because think about whether it is functional dimension, whether it is circle, and whether it is reference dimension under your control, while one by one creating the dimensions, showing the dimensions, you may not make a mistake. But if the time is limited and you have no more time to show the entities one by one, it takes greater time, then recommend use this facility. Okay, baseline dimensioning or chain dimensioning. Baseline dimensioning. I selected baseline. Okay, and then on this view, using windowing method, show the projection, and then right click the mouse, say continue. You see? Now I selected all of them and then move the cursor in this direction, and then if Inventor finds an entity, then for all the detected entities, well, show the dimension with one click. But you see, although it is a facility, but for instance, this dimension, no need to show this dimension. And you know the rule, if on the projection entity is hidden, then we don't show the dimensions. But Inventor, in using this tool, couldn't distinguish that these are hidden, so show their dimensions. It is wrong. Although it is a facility, but it is not recommended to use, because Inventor cannot distinguish whether that dimension is to be shown. But of course, you can do this. Well, after starting the baseline process, indicate the features, not using windowing method all, but some of them. For instance, I indicated this one, that one, this one, and this. Right click the mouse and then continue. Then only indicated ones, then Inventor show the dimension. Yes, similarly on the front view, right click thereafter, and then don't forget to click on create button. Well, similarly, clicked on baseline dimensioning option. If it is to be shown in form of a chain, then clicked on chain line. But it is, datum dimensioning is preferable. Clicked on this and then indicate this, indicate this, indicate this, and then right click the mouse and then say continue. Only for the indicated ones, you see Inventor created the dimensions. How you can finish the running? Right click the mouse and click on create button. Have an idea? Well, it takes a shorter time, but you should be careful. for which entities need to show dimensions, only indicate those entities. Then the space value automatically set by the software and the numbers placed, well, it is a convenience. If the time is limited to show the dimensions one by one, then I recommend click on this and then show. If it is chain dimensioning, similarly, click on this button and then indicate this, indicate this, indicate this, this, and the other, and then right click the mouse and continue. Okay. Chain. Yes. Indicate this. And that. Indicate this one. Indicate this one. Indicate this and that. Right click the mouse and continue. And move the cursor in this direction. Then vertical dimensions are shown. In that direction, the horizontal distances are shown. Dimensions are shown in the horizontal direction. Click, locate it, and don't forget to right click the mouse and click on create button. That is it. At a shorter time, you can show the dimensions, not by one by one. Okay, dear students, ending this video record. See my face one more time. Who is speaking? It is me, Murat Sönmez. Okay, I'm an associate professor in Middle East Technical Northern Cyprus campus, mechanical engineering. Stay healthy, my dear students. Bye bye.